When we look up at the starry sky, we rarely think about how and where these luminaries are born. Stars are not just sources of light, but colossal factories where the chemical elements necessary for life are formed. Their journey begins in amazing places called nebulae. What makes nebulae true factories of stars, and how do their chaotic material form orderly star systems? Let's get to the bottom of it. What are nebulae? Nebulae are giant clouds of gas and dust scattered throughout the universe. They are composed mostly of hydrogen, about 90%, helium, about 10%, and small amounts of heavier elements called metals. Their size is staggering. Some nebulae can stretch for hundreds of light years. Nebulae are divided into several types: emission nebulae, reflection nebulae, dark nebulae. Emission nebulae, luminous clouds that emit light due to the energy of young stars. Reflection nebulae, clouds that do not glow themselves, but reflect the light of nearby stars. Dark nebulae are dense regions of gas and dust that block light from stars or galaxies beyond them. An example of one of the most famous nebulae is the Orion Nebula, about 1,344 light-years from Earth. It is actively used by astronomers to study star formation. How do nebulae become star factories? The star formation process is triggered by gravity. But the key factor is the initial disturbance inside the nebula. It can be triggered: a shock wave from a supernova explosion, interaction with another nebula or interstellar cloud, passing through dense regions of galactic spiral arms. The perturbation causes parts of the nebula to begin to shrink under the action of gravity, forming dense regions, protostars. These regions eventually heat up due to gravitational energy. Did you know? Thousands of stars can form simultaneously in one large nebula, with masses ranging from tiny dwarfs to giants, whose lifetimes are much shorter because of their high brightness. The birth of a star, the stages. The process of star formation can be divided into several stages. Cloud collapse. Gravity forces gas and dust particles to compress at the center. A protostar, a core surrounded by an accretion disk, gradually forms. The protostellar phase. Inside the protostar, the temperature and pressure continue to rise. When the temperature at the center reaches about 10 million degrees Kelvin, thermonuclear fusion, the conversion of hydrogen into helium, begins. Main sequence phase. The star becomes stable, balancing the forces of gravity and pressure created by the thermonuclear reactions. During this phase, the star spends most of its life. Star systems, how do they form? In addition to forming stars, nebulae play an important role in the creation of stellar systems. Residual material from the accretion disk around the star forms planets, asteroids, and comets. This happens in the following way. Particles sticking together. Dust and gas particles collide to form planetesimals, the small rudiments of future planets. Growth of planetesimals. Under the action of gravity, planetesimals attract more and more material to themselves, becoming protoplanets. Planet formation. In the final stage, protoplanets clear their orbits of residual gas and dust, becoming full-fledged planets. Do you think Earth-like planets could exist in star systems like ours? Examples of known nebulae and their role. The Orion Nebula. One of the closest star-forming regions to us. Scientists observe the formation of new stars here. Eagle Nebula. Home to the famous pillars of creation, giant columns of gas and dust where stars are being born right before our eyes. The Rosette Nebula. An amazingly beautiful area of star formation where young stars illuminate the surrounding gas, making it glow. Why do stars form specifically in nebulae and not in other parts of space? What is the future of stars born in nebulae today? Why is the study of nebulae important? Nebulae help scientists understand the origin of stars, planets, and even life itself. By studying them, we can learn how the solar system formed, understand the conditions necessary for life to originate, assess the future of star systems and galaxies. Before summarizing, it's worth noting a few surprising facts about nebulae. The largest nebula visible from Earth is the Andromeda Nebula, about 2.5 million light-years away. Its dimensions are about 220,000 light-years across. The brightest nebula in the night sky is considered to be the Orion Nebula. It can be seen with the naked eye and is used by astronomers to study stellar maternities. Some nebulae, such as the Crab Nebula, are remnants of supernovae explosions and carry information about catastrophic events in the history of the universe. Nebulae are not just beautiful objects decorating the cosmic expanse. They are real factories where stars and planets are born, including systems like our own. Their study opens before us not only the mysteries of the past of the universe, but also helps us to look into its future. Who knows, perhaps one of the stars now being born in a distant nebula will become home to life. Wouldn't that be amazing? What do you think about the future of nebula research? Will scientists be able to create artificial stars or even entire star systems in the future? One of the most significant discoveries in the study of nebulae was the use of the Hubble Space Telescope. In 1995, images of the pillars of creation in the Eagle Nebula stunned the world by showing the process of star formation in unprecedented detail. Subsequently, in 2022, the James Webb Telescope looked even deeper into the structure of these regions, revealing fine details of gas and dust. These studies confirm that nebulae play a key role in the evolution of galaxies and the universe as a whole. Perhaps future discoveries will allow us to better understand the origin of not only stars, but life itself. Who knows what else the universe hides in its distant nebulae? If you enjoyed this journey into the world of nebulae and stars, don't forget to subscribe to the channel so you don't miss more fascinating stories about the universe.